Hello friends, in this video we are going to study that what is a transducer, why there is a need of transducer in measurement system, and then we will study some of the examples of transducers. So let us start with our topic. We know that in an electronic instrumentation system, it consists of a number of components which are doing the measurements and giving their output as the results of the measurements. So in an instrumentation system, we are having the components which are doing the measurement. So in a measuring device, we are having the input and this measuring device is giving the result or the output to us. So if we describe a general measurement system, it is consisting of three devices or three components. One is the input device. Second is the signal conditioning or processing device. And third is the output device. So any measurement system, it is going to consist of these three components: input device, signal conditioning or processing device, and the output device. Now what the input device does, input device is going to receive the measurement or the input signal, means the quantity which we want to measure. The signal conditioning or processing device, it is going to do the processing over the signal, like it is going to amplify, filter, modulate, or it is going to attenuate that signal. So all the signal conditioning will be done by this signal conditioning or processing device, and then the output, which is the acceptable output format, it will be given by the output device. So that is the function of these three components of a measurement system. Input device receives the measurement. The signal conditioning or processing device, it is going to do the processing of the signal, like it is going to either filter, amplify, attenuate, or modulate the signal, and it is going to give that signal, the modulated or the signal processed signal, to the output device, and output device is going to give us the result of the measurement. Now here the input device, you can see here that it is receiving the measurement, that is the input signal. Now in the measurement system, in most of the measurement or the instrumentation system, this measuring, it is a non-electrical quantity. Okay, so this non-electrical quantity which is measured by this measurement system, this there are possibilities that nowadays you can see that most of the methods and most of the techniques, they are using the electrical signals. Now here the input signal is a non-electrical quantity, so problem occur in the instrumentation and measurement system, that how this non-electrical quantity is to be used by the electrical methods. So there is a need for the conversion of non-electrical quantity into an electrical quantity, and for that a device is developed which is doing that conversion, and this device is known as the transducer. So transducers, we can say that they are the devices which convert the non-electrical quantity into an electrical quantity, so that that electrical quantity can be used for other systems in the instrumentation and measurement systems. Okay, so that they can be applied to the other components. So we can say that why there is a need for the transducer. The need occurs because if we want that these non-electrical quantity, if we want to do some electrical processing over it, like for the measurement, manipulation and for the control systems, we have to apply electrical methods. So to use those electrical methods, we have to convert the non-electrical quantity into electrical quantity, and that is why transducers are developed, and that is why there is a need for the development of the transducers. So if we define transducer, so transducer is a device which converts a non-electrical quantity into an electrical quantity. Now, we know that any form of quantity or any object, it is going to have some energy in it. Okay, so non-electrical quantity, it is also some form of energy, and an electrical quantity is also some form of energy, that is electrical energy it is. So we can also define the transducer as a device which converts one form of energy into another form, or we can say that one form of information is converted into another form. Like mechanical energy can be converted into electrical energy can be converted into optical energy. Okay, so in this way one form of energy is converted into another form by the transducers. So another definition for transducer is so due to these properties of the transducer, that it is converting non-electrical quantity into electrical quantity and one form of energy into another form, that is why they are widely used in the measurement system. Because in measurement system there are some situations in which the output quantity is not which can be correctly displayed or measured. Okay, there are sometimes situations, so the to convert those non-electrical quantities into some measurable or displayed form, we are using the transducers. Okay, if we see one example of it, that why there is a need of the transducers and why there is a need for this conversion, let's take an example of a mercury thermometer. Now suppose if we want to measure the variations in the temperature, suppose we are having a room and we want that we want to measure the variations in the temperature of this room. So how we are going to measure these variations? There should be some device. So here the mercury thermometer is used. Mercury thermometer is going to measure the variations in the temperature by measuring the variations in the length of the mercury column. You can see that in mercury thermometer we are having the scales here. In mercury thermometer we are having a column in which the mercury is filled, and on that we are having the scales over it. Okay, now this mercury column is filled with the mercury. So according to the variations in the temperature, this mercury column is going to, mercury in this column is going to raise its level. So by measuring the level of the mercury, we are measuring the variations in the temperature. Otherwise, it will be not possible for us to measure the variations in the temperature in a room. Okay, there is no method for that. So what we are doing, we are changing the variations in the room temperature by into the variations in the level of the mercury column. So in this way, the temperature is converted into the level of the mercury. Okay, and in this way we can measure the temperature variations. Another example is manometer. Manometer is used for measuring the pressure. Okay, so directly we are measuring the pressure variations in a system, that how the pressure is changes. The manometer is going to directly give us the readings over the scale. Okay, over the calibrated scale. So here you can see that how the a quantity which cannot be measured directly, it is converted into a form that can be measured and that can be displayed. Okay, like temperature variations, pressure variations, all these are non-electrical quantity, and how these non-electrical quantity or one form of energy is converted into another form by the transducer. So all these mercury thermometer, manometer, all these are a type of transducers which are converting one form of energy into another form. Now there are many physical parameters, like we are having heat, intensity of so not only the temperature and the pressure variations, but also the other physical quantities, physical parameters like the heat, intensity of light, flow rate, liquid level, humidity, pH. There are no methods, no direct methods for the measurement of these quantities. So we are going to use the transducers. Transducers are going to convert these physical quantities into an electrical quantity, and then we can easily measure the value of these parameters. So transducers, in all these cases, whenever the transducer is converting the energies, so transducers is going to provide an output signal whenever it is stimulated by a mechanical or non-mechanical input. It is not necessary that always the physical quantity, the non-electrical quantity, it is a mechanical quantity. Okay, it can be acoustic or it can be any of the form. Okay, it can be a pressure, it can be force, it can be heat, light, anything. So any non-mechanical or mechanical input, it will be converted into an electrical output. Okay, now, as the output given by the transducer, it is an electrical output or it is some form of energy. So, there is a division of transducers on the basis of the output, nature of the output. Like if the output is an electrical quantity, it will be an electrical transducers, mechanical transducers, acoustic transducers. So, depending upon the nature of the output given by the transducers, they are divided into different categories. Most probably we are going to use the electrical transducers. They are widely used and they are having applications in many fields, because most of the systems, instrumentation and measurement systems, they use electrical methods. Okay, so they use electrical quantities, so there is always a need for the electrical transducers which convert a non-electrical quantity into an electrical quantity. So if we, this is how we define the transducers, that transducers are the devices which convert one form of energy into another form. Okay. Now, if we talk about that, what a transducer consists of. So, transducer, it basically consists of two elements. One is the sensing element and second is the transduction element. Sensing element is going to sense the input signal, and transduction element, it is going to do the conversion. That is the conversion of non-electrical into electrical. Okay. So, if we say that a transducer So these transducer, it consists of two components, sensing element and transduction element. If we draw the block diagram that how in a measurement system the transducer it can do the conversion. First we are having the non-electrical quantity. So this is the block diagram of the transducer. It is converting non-electrical signal into an electrical signal. First is the sensing element. So sensing element is sensing the non-electrical quantity, then giving the sensor response to the transduction element, and this transduction element is doing the conversion. So sensing element, it is going to sense the physical quantity or the rate of change in the physical quantity, and it is going to give the response to the transduction element. Transduction element convert the non-electrical signal into its proportional electrical signal. So you can see that this transduction, the process of conversion of a non-electrical to electrical signal is called the transduction, and the element which is doing this is called the transduction element. Now the transducer, it uses many effects to do this conversion, and depending upon this effects, there are various types of transducers available. Okay. Now there may be also cases where the transduction element, it is performing both the sensing part and the conversion part. Okay, so sensing part means to sense the input quantity, and transduction part means the conversion part. So there may be that in the transducers both the sensor and transduction element are present, or there may be cases that only the transduction element is present. One example of a transducer is a thermocouple. Okay, so the best example of the transduction element which performs the action of both the transduction and the sensing is a thermocouple. You can see that in the thermocouple, it generates a voltage whenever there is a change in the temperature at the junction of two metals. In the thermocouple, we are having two metals which are connected with each other, and this at this junction we are doing the temperature changes. Okay, at one time it is kept at something 0 degrees Celsius, and after that it is kept at some temperature other than this, and then due to this temperature difference, the heat which is generated, that is converted into the voltage. So you can see that a non-electrical quantity heat is converted into an electrical quantity, which is the voltage. Okay, so this thermocouple, it is acting as the sensing element also and transduction element also. It is it is sensing the changes in the input signal also, and it is generating the electrical signal also. Okay. If we see some other examples of transducers other than this thermocouple, then other examples of transducers are Microphone. Microphone is also an example of transducer because it converts the sound, which is a non-electrical quantity, into the electrical impulses. Okay. Another example is the light bulb. You can see that the light bulb is converting the electrical energy into optical energy. So it is not necessary that always the output is an electrical output. It can be because we have defined the transducer that as a device which converts one form of energy into another form. So here you can see that the electrical form of energy is converted into optical form of energy. So that this is also a transducer. Another example is the electric motor. The electric motor is also a transducer because it converts the electricity into the mechanical energy. So here also you can see that one form of energy is converted into another form. So in this video we studied that what is a transducer, why there is a need of transducers in the measurement system, what's the need that arises the development of the transducers. Then we see that what is the block diagram, what are the two components of the transducer, sensing element and transduction element. Then we see some examples of transducers. So I hope that this topic is now clear to you. Thank you.